Alright, now, I would like to go ahead and warn you up front. Some of our students found Chapter 9 or Module 2 in Math 65 to be one of the hardest ones. So be prepared, but don't be afraid of it. If you just follow what I'm telling you, you're going to be okay. Now, review my 5 steps for solving equations, which you saw in Chapter 3. So I'm just reviewing. The first step is to simplify either or both sides of equals by doing what it says. Now second, if there's an x or a variable on both sides of equals, always and forever take small x to big X by either adding or subtracting, because you're taking the x with it. The third step is to eliminate whatever is added or subtracted to the x by doing the opposite. Step 4, eliminate whatever is multiplied or divided to the x, again by doing the opposite. Remember to take the sign with it. Step last, check by putting it into the original problem. Now, number 1, simplify either or both sides of equals. That side I can't simplify, but this side I can. If I owe 2 and I owe 6, then I owe 8. Is there a y on both sides? No, so I can ignore step 2. Is there something added or subtracted to my y? Yes. -5 is added, subtracted, so the opposite is to add it. And remember, if you owe $8 and you only pay $5, you still owe something, so your answer is negative. And 8 minus 5 leaves us 3. So when they're the same sign, you add them and you keep your sign. When they're opposite signs, you subtract them and you keep the sign of the one you have more of. Now on this problem here, I would simplify these first before you do anything. And if you take 0.9 times 20, that gives you 18. So 0.6x, notice I dropped the 0 because I don't need it anymore. Now 0.3 times 60, also gives you 18. Whoops, and there's a plus in the middle here. The opposite of, okay, so I simplified both sides of equals. There isn't an x on both sides, so I can skip step 2. Is there something added or subtracted to my x? Yes. 18 has been added. The opposite is to subtract it. Chop, 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 chop. When this happens, I've got 0.16 times x equals 0. And then when I divide both sides by 0.6, because the opposite of timesing is to divide, then x equals 0 still. And notice every once in a while I do box in my answers so that hopefully sometime you'll get into the habit of it. Well, number next, there's nothing I can do to that side of equals. And if I look at that side of equals, there's nothing I can do to that side either. So, small y to big Y, because a negative y is definitely smaller than a positive y. So I have to add 5 y's to both sides. And notice I can only add them to their like terms. So 13 equals 10y minus 17. Now, I got my y's together on one side. Now eliminate whatever's added or subtracted to the y. Well, guess what? There's no y on that side with 13, so do not move it or touch it. But there is a 17 that is subtracted, so the opposite of subtracting 17 is to add 17 to both sides. And again, I have to add them to their like terms. So that leaves me 30 equals 10y, 10 times y. And the opposite of timesing by 10 is to divide by 10. So my y equals 3. Now, I'm going to teach you something new. Well, it probably isn't new because I think I've taught it to you before, but a whole number is a fraction over 1. Now, I've got one fraction equal to one fraction, so I can cross multiply. And it has to go from lower right to upper left, equal to lower left to upper right. So 1 times 6 parentheses y minus 3 is 6 times y minus 3. And you say equals, and you say 5 times negative y. We distribute, so it's 6y minus 18 equals negative 5y. Always, always, and forever, small y to big Y. The opposite of subtracting 5y's is to add 5y's. And that gives us 11y minus 18 equals 0. Now, I need to take my negative 18 over. The opposite of subtracting is to add it. And 11y's equal 18. The opposite of timesing by 11 is to divide by 11. And believe it or not, they want the 18 over 11. If it had been 18 over 12, we could have divided a 2, actually a 6 out of top and bottom. But in this case, there's nothing that divides out, so this one is done. Now here, there's a slight little cheat. There's 2 decimal places in every term. So we can times by 100, times by 100. And remember in the chapter on decimals in chapter 5, where we multiplied by powers of 10, however many zeros there are, that's how many times the decimal place moves to the right. So that leaves us 14 minus 1 times x plus 3 equals negative 3 times 2 minus x. Then we distribute the negative 1 on the left and the negative 3 on the right side of equals, and that gives us 14 minus x minus 3 equals negative 6, and a negative times a negative is a positive 3x. 14 minus 3 is 11, minus x equals negative 6 plus 3x. Get our x's together. So hang on just a second. Step 1, which is simplify. Sometimes it takes more than one time to actually get it simplified. Now, get our small x to our big X. So the opposite of subtracting x is to add x. So 3 plus 1 x's gives us 4. So plus 4x. And now the opposite of subtracting 6 is to add 6. Notice I'm starting to shortcut. So 11 plus 6 is 17 equals 4x. And then the opposite of timesing is to divide. And this does not clean up. So we're left with 17 over 4, and yes, they still want the ugly fraction. Now, distribute on number 6, distribute the 5, so 5x, and then plus 35. And I want to give you a clue on something. These parentheses mean absolutely nothing. So just get rid of them. They do that to see if you know to ignore them. Oh my goodness, what just happened? 5x equals 5x, 35 equals 35. Ooh, these are exactly the same line. Alright, when this happens, where are the same lines equal? You got it. They're equal everywhere, which means all real solutions. It may say all real numbers, it may say infinitely many solutions. All of them mean the same thing. All real numbers are all real solutions. Now, again, one fraction equal to one fraction, you cross multiply. So 5 times 5 is 25 times x plus 3 equals 4 times 4 is 16 times x minus 3. And we take 25 times x plus 25 times 3 equals 16 times x minus 16 times 3, which is 48. Now, small x to big X, always, always, and for what? Forever. So 25, and the opposite of adding 16 is to minus 16. So that leaves us 9x's plus 75 equals negative 48. Then we subtract 75, and that's ugly. So if you owe 48 and then you borrow 75 more, you owe 123. And then you take 123 divided by 9. Ooh. Well, I can divide these both by 3. So that gives us negative 41 over 3. And that's a gross answer, but it's the right one. Now, number next, 3x plus 1, and we have to distribute our 3. So 3x plus 3, small x to big X. Well, there isn't a small or a big, they're both the same. So when I subtract 3x from both sides, I get 1 equals 3. What do I do with that? Is that true? No. It wasn't in my day in high school and college, and it isn't in your day either. So when this happens, these are parallel lines. Whoops. Yeah, I can't write. Parallel lines have no solution because they're parallel. Parallel means that they run side by side, which means they never cross. So if they never cross, there can't be a solution. Alright, here we go. We're getting close to the end of this one. So negative 3 times x is negative 3x. Negative 3 times positive 3 is negative 9 minus 9 equals negative 16. Well, this gives us negative 3x minus 16 equals negative 16. Then I could add 16 to both sides, and that gives us negative 3x equals, whoops, chop chop and chop chop, equals 0. Well, just like with number 2, if it equals 0, then x equals 0 also, because negative 3 times any number but 0 is not going to be 0. Now, oh yuck. Are you friends with fractions? Then you are going to like this problem. If you're not friends with fractions, let's kill the fractions up front. We have an LCD, or we have a fraction with a denominator of 3, denominator of 1, denominator of 1, denominator of 5. So our LCD is 15. So we times by 15 to every term. And I know this is kind of getting, yeah, this kind of got really ugly looking right here and ran everything in together, so I'm just going to do this. 15 times your numerator, divide by 3, minus 2 times your numerator, 2 times 15 over 1 equals 3 times 15 over 1 plus 15 times x over 5. Now 3 goes into 15 5 times. Well, I don't have to worry about ones. Then 5 goes into 15 3 times, so that leaves us 5x minus 30 equals 45 plus 3x. Small x to big X, always, always, and forever. So minus 3x's from both sides. That leaves us 2x's minus 30 equals 45. Then we add 30 to both sides. And 2x's equals 75. And we're going to get an ugly number here. So 2x equals 75. Divide by 2, divide by 2. And if your instructions say put a decimal, then you would take 75 divide 2, and that would be 37.5. If it says in a simplified fraction, then this is what they want. If you have questions, just ask.